Hello and welcome to Chapter 1, Section 1, Functions. Today we will use set notation to denote elements, subsets, and complements. I will describe subsets of real numbers, identify and evaluate functions, and state their domains. Here's the vocabulary for your section. Please copy it down and find out their definitions. Okay, key concept of real numbers. We have the letter Q, which stands for rational numbers, and here are some examples of rational numbers. I, the double I looking, is irrationals, and there's an example of an irrational number. Z stands for integers, and there's some examples of integers. W for whole numbers, and there's your examples for whole numbers, and N for natural numbers. And you see a Venn diagram that also shows you the real numbers. Okay, we're going to be using set builder and interval notation. So first, let's look at this using set builder notation. Okay, this is a set that includes natural numbers greater than or equal to 2 and less than or equal to 7. So we would write it at set builder notation as x such that 2 is less than or equal to x is less than or equal to 7, where x is an element of the naturals. You wouldn't be able to write that in interval notation. Now we have an inequality, x greater than negative 17. We're going to use set builder notation, and we're also going to use interval notation. And x is is a set of all real numbers greater than negative 17. So that one's an easy one as far as set builder. X such that x is greater than negative 17, where x is an element of all real numbers. Now, if we were to write this in interval notation, we would start at negative 17 and go to positive infinity. There would be a parenthesis with positive infinity because infinity never ends. And since it's not equal to negative 17, we have a parenthesis at the other side. So now we have set builder notation and interval notation for x greater than negative 17. Next, we're going to describe all the multiples of 7 using set builder notation. That is the set that includes all integers that are multiples of 7. So we have x such that x is equal to 7n, where n is an element of integers. Okay, and there's our set builder notation. Okay, key concept about functions. A function f from set A to set B is a relation that assigns to each element x in set A exactly one element y in set B. This relationship is a function because x only goes to one place. The domain is 1, 2, 3, and 4, and the range is 6, 8, and 9. Key concept about the vertical line test. A set of points in the coordinate plane is the graph of a function if each possible vertical line intersects the graph in at most one point. So if we moved our vertical line either direction, it would only intersect the relation in one point. Determine whether the relation represents y as a function of x. The input value x is the height of a student in inches, and the output value y is the number of books that the student owns. Since there is more than one y value for an x value, no, this is not a function. Next, we're going to determine whether the table represents y as a function of x. And as we're looking at it, we see we have x going to more than one place. So no, there is no function because we have two x's going to two different places, two of the same x's going to the same place. In other words, our x's are repeating. We can easily check to see if this graph represents y as a function of the x. We can do that by, we can use the vertical line test to see if it is a function. So as we move our vertical line through, we see it only hits the function in one place wherever we draw our vertical line. So yes, this relation is a function. To determine if a given relation is a function, we need to make sure that the equation is solved for y. So we take x equals 3y squared and solve for y. So we would divide by 3, and x over 3 equals y squared. Okay, well, that gives me, when I take the square root of each side, that gives me y equals plus or minus the square root of x over 3. Okay. With it looking like that, that would make it look like a parabola on its side, like this and like this. Well, when we look at the graph, we can easily see that that is not a function. Okay, to find the value of a function at a certain point, and in the case of our problem, we have f of x equals x squared minus 2x minus 8. We want to find f of 3. That means all I do is wherever I see x, I'm going to put in 3. So that's f of 3 equals 3 squared minus 2 times 3 minus 8. Okay, that's going to be 3 squared is 9. 2 times 3 is 6. And that's minus 8. Now using order of operations, all I have to do is go straight across. So 9 minus 6 is 3 minus 8 equals negative 5. Now, using the same function, we're going to replace x, this time with negative 3d. So let's look and see what happens. We've got f of negative 3d equals negative 3d squared minus 2 times negative 3d minus 8. Okay, we look at the first term. The negative 3 squared is going to give me 9, and d squared, of course, is d squared. Negative 2 times negative 3 is positive 6d, and then we have minus 8. So when we evaluate the function, we get 9d squared plus 6d minus 8. Okay, using the same function, this time I'm going to replace x with 2a minus 1. So I've got f of 2a minus 1 equals 2a minus 1 squared minus 2 times 2a minus 1 minus 8. Okay, so that's going to give me 4a squared minus 4a plus 1, and then multiplying through by the negative 2, that's going to give me negative 4a plus 2 minus 8. Okay, now I collect my like terms, and I get 4a squared minus 8a minus 3. Okay, so now we know that f of 2a minus 1 is 4a squared minus 8a minus 5. Since this function is a square root function, we know what's underneath the radical has to be greater than or equal to 0. So we just set 4x minus 1 greater than or equal to 0. So we solve, adding 1 to both sides, and we get 4x is greater than or equal to 1. Divide through by 4, and x is greater than or equal to 1/4. Okay, you can write it either as x is greater than or equal to 1/4, or you could write it in interval notation, 1/4, comma, positive infinity. When dealing with a function like h of t is equal to 3t squared over t squared minus 1, which is a rational function, we have to find out where the denominator is 0. That will help us with our domain. So t squared minus 1 equals 0. That's our denominator. And we want it not to be 0. So let's go ahead and solve this, adding 1 to both sides, and we get t squared equals 1. Take the square root of both sides, and t equals plus or minus 1. So now we know that is the places where we can't have is not a part of the domain. So to me, the easiest way is to write this in interval notation, which is negative infinity to negative 1, and negative 1 cannot be included, union negative 1 to 1, union 1 to positive infinity. All of them are parentheses because none of them can be included in the solution. Okay, this problem is similar to the previous problem in that we have to work with the domain. But in this case, the denominator, the 2x minus 3, has to be greater than 0 because it is a square root. So we're going to just solve that. So 2x minus 3 has to be greater than 0. Okay, so we go ahead and solve, add 3 to both sides, and we get 2x is greater than 3, divide both sides by 2, and x is greater than 3/2. Okay, you can write it in set builder notation or interval notation. Since it's a greater than, we know that 3/2 is not included in the solution. So it goes from 3/2 to positive infinity. Okay, our last question is a piecewise function. We have a finance realtors in the metropolitan area studied the average home price per square foot as a function of total square footage. Their evaluation yielded the following piecewise defined function. Find the average price per square foot for a home with the square footage of 1,400 square feet. Well, first thing we need to find out is which interval is 1400 in. We have our first interval here from 1000 to 2600. Our second one is from 2600 to 4000. And our last interval is anything greater than 4000. We can see that 1400 is going to be in this interval. So that means we use this function. So we're going to use a minus 1000 over 40 plus 75. Okay, our A is 1400, the total square footage, minus 1000 over 40 plus 75. Okay, that's going to come out to be 85. So that means that the price per square foot is $85. Okay, that's our lesson for Chapter 1, Section 1. Thank you.